right. Hello, folks. It's been a while since I've been streaming. I figured I would get back into it, so we're going to kick off with a short stream today. I figured I'd play some programming games. I like to program. I'm a software engineer, so I'm a big fan of Zachtronics as well. So I wanted to do some of their games. This one's TIS-100. It's kind of like a programming this old kind of novel computer design that they've developed. So it's pretty neat. I have played this game before, but it's been quite some time, so I'm getting back into it. So we're just going to dive right in. Let's start with the initial. Got my printout here of all the things that I'm supposed to have, the instruction manual. So if I need to reference something, I'll look it up there. Normally I use the PDF, but for now I'm not going to. All right, so I did do this one while I was getting some settings configured, so I kind of already know what to do here. The in.x, we're moving values from the in-x and in-a to the out-x and out-a, and so in-x is just straight down. In-a, we've got to kind of go around this broken node here, so we'll move the top value to the left here, and then I think, can I figure out, yeah, there we go. Okay, then we can move the right value down, and then we can move I'm going to keep typing move with an E. It seems like we're just going to go straight down there. We're going to move the upside to the right, and then we're going to move the left down. And that should do it. If we run it, that gets us all the way. Yeah, we're good. Good. Cool. Let's see. Let's turn to the segment list. So let's move on. Next up, let's see what we got. Read a value from in.a, which is here. Double the value. Okay. And then write the value to out.a, which is over here. So I guess what we can do is we'll just move up, down, and then here we can move up into the accumulator, and then we can add the accumulator, and then move the accumulator down. I don't know why I picked down here. Then we can move up to the right. I could have gone this way. Either way, doesn't really matter. And we'll move left down. That should do it. If I can spell down correctly. I want to see what this debug thing says. Continued chatted with Bernie at IBM, and he says it sounds like something they'd O_in.a come up with in the USSR, but then why is the manual in English? I think this ties back. I didn't click on the one in the previous level. I read it already. I haven't done the kind of like metagame. I assume there's a metagame here. So I just out of curiosity, what if I write to that? Is that going to break something? So if we step through here, move that down. Yeah, nothing happens. So we'll see if we can figure that out. Let's run this. That seems to be correct. So, yeah, we did it. We are good. Back to the list. Over here. Ooh, this one's got some spread on it. Let's see what we got. Read values from in.a and in.b, and write in.a, in.minus in.b to out.p. Write in.b minus in.a to out.n. Okay, interesting. So we need to get A and B on the same node so we can do our subtraction. But what I think I'm going to do is I'm probably going to read A in and push it down, and then I'll read in, and then I'm going to read it in again and push it, or not read it in again, but I'll push it this way. So if I move up into accumulator and then move the accumulator down, move the accumulator to the right, and then over here, if I move up, down, accumulator, move the accumulator down, and then move the accumulator to the left. Then I should be able to move. Actually, I probably need to move left down here, and then I can move right down as well. So that should pass in. Just for now, we're gonna move. We'll just add up. We'll just add it so we can assume that value that's coming in. Let's step through. Let's see. We've got that goes into the accumulator. Then they both go down. Then 44 gets written over here. We read it, move it down. 93 goes down. And we got 137 on both sides. Okay, cool. So we've got the values coming in. So over here, we have A coming in first, which is what we want. And then we want to subtract B from it. So if we move up into the accumulator and then we sub up, then we should be able to move the accumulator down, and then we can move up down. That should cover, I want to say that should cover that case. I think I need to still, let's leave that there for now. So let's see what we've got. 78 coming in. Not 78. What do we got? 44, 93. So negative 49 should be out.p. Yep, we got negative 49, and that should go down, and that's out. Okay. So we got one up, and then the other side should be just kind of the opposite. We have B coming in first, so we're going to move up into the accumulator, and then we're going to sub up, and then we're going to move the accumulator down, and then here we can just move up, down. And that should do it. That looks correct. Perfect. I am on the high end instruction counts, but seem to be okay. Instruction counts high, cycle counts high. I'm wondering, because it's going to be the same, right? If we just flip it, I don't think there's a multiply. I do not think there's a multiply in here. Come on, there we go. Okay. Got reading. Come on, can't really turn these pages very well. Okay, got swap, move, swap, save, add, sub. Oh, we have a negate. We have a negate. Look at that, negate. So we can see the pattern here that negative 49, positive 49, positive 18, negative 18, positive 4, negative 4, positive 4. So what I'm thinking is we just kind of do this, where we move this to the left down here. We don't need this code anymore. We will change that. So we're going to move B over to A, and that's going to write both of those down just like it has been. We're going to do the same thing. We're going to move this down. So here we're going to move that to the accumulator, then we'll move the accumulator down, and we'll move the accumulator to the right here. And then over here, we'll move the left into the accumulator. We'll negate. Come on. I saw the negate command and immediately closed the book. Let's actually read up on it. Where are you at? Negate. Yeah, negate. Syntax, just negate. The value of ACC is arithmetically negated. Cool. All right. So what we'll do is we'll do that, and then we'll move ACC down. That should reduce our instruction count, and that should get us the right answer. Okay, we've got a deadlock. What is our deadlock? Because that one's going to write first. So we need to move right. Oh. I don't need you. That's the problem. Nope, I do need you. I don't need this line anymore. There we go. And so yeah, that's pushing out the values that we want. That gets us down in the lower end. Still 13 on instructions. I'm wondering Can I reduce instructions more? I don't need to move this into the accumulator, so that's a wasted instruction. So if we go up, straight down, and then move up to the left, and then right down, move up into the accumulator, and then sub up, and then accumulator down. Seems to make sense. Move up into the accumulator because we need it, and then we do store in the accumulator here. We already have it in the accumulator here. I'm wondering if we could just negate it, then move it to the right. Then we can move left down, and that cuts this from 3 to 1 by adding 1 instruction there. We still get the right answer. We're down to 11. I think I'm going to be happy with 11. Cycles went up a little bit. I'm pretty happy with that. All right, let's see what we got here. Read a value from in. Okay, write 1 to out.g if n is greater than 0. Write 1 to out.e if n is equal to 0. And write 1 to out.l if n is less than 0. When a 1 is not written to an output, write a 0 instead. Okay, so we need to get the values down here. I noticed, did I miss one? Let's go back to the segment list here. Back over here, there was, oh, this is the one we're looking at. Back to the segment list over here. I did miss a debug, didn't I? What do we got? Interesting. It looks IVD $I at SI, there's some kind of static memory in this thing encoded to something or other. Yeah. Interesting. Probably have to piece that together once we get all of this stuff. Back to the segment list. This is the one we're on. Yeah, here we go. Okay, so none of these nodes are going to be used because we need down here. So we're basically just going to move up, down, move up, down, move up to the right. All right, so now we have our value coming in here, so we want to move right into the accumulator, because if I recall correctly, our jump commands all work off of the accumulator. Where are you at? Jump, we've got JMP, standard jump to a label, transfer execution unconditionally, okay. JE0, so that jumps of 0. This instruction after the label will be executed next if the value of the accumulator is 0. JNZ, which is jump not 0, JGZ greater than 0, JLZ less than 0, JRO, transfer execution unconditionally. The instruction at the offset specified by source relative to the current instruction will be executed. Interesting. Okay. Okay, that's interesting. Okay, so J and Z, JGZ, JEZ, and JLZ. Okay, so out.g is greater than 0, so JGZ to, I guess, out. We'll just call it out. So we'll put out there, move ACC down. And then here we'll move I always need to put a start here, I guess. Move ACC to the left. No, right. Get my directions mixed up there. And then we'll jump back to our S. Over here, I mean, we're gonna have the same logic on all of these, except for you. Ooh, no, we don't want to write ACC. We want to move. No, we do want to write ACC there. We want to move 1 here, and I forgot we need to move 0 down. Actually, what we can do is we can kind of combine this No, let's just do it this way because I think this will result in fewer tokens. Okay, and then we're moving one down. Over here, we're moving right into the accumulator, and out.e is if we're equal to 0, so that's easy. And then, we should copy this new code, shouldn't we? Yeah, let's get that over there. Nope, we don't need it over there still. Okay. Changing that to easy, because then the accumulator goes right. If it's not equal to 0, 0 down, and we just jump back to the start, and we move 1. Okay, and then here, if we get to this point, we're done. So we just move 1 down. I guess technically, actually, no, we do need all this code because we need to write out, so we need the value over here regardless. So we'll always write to the right, always send the value onwards to the right because we need to move it along and then test it locally. Now this node doesn't need to move it along, but we just need to out 1 if it's less than 0. Otherwise, start back at the top. That should do it for us. What happened? That's what happened. This is left. Move left into the accumulator. Yep. Unfortunately, I do get left and right mixed up more than I'd like to admit. Okay, now it looks like we're doing good here. There we go. Okay, hey, we actually did pretty good. Look at that. I'm happy with that. No complaints there. We did miss, what is this one? I skipped it earlier. Oh, this was a big one. Found a block of static memory, but it's in a proprietary format I never saw before. Can't make heads or tails of it. Oh, brother. Too many different kinds of machines coming out now. I like tinkering. The next have when every Tom, Dick, and Mary implements their own memory address scheme. It's all jumbled. I say the bottom's going to drop out of this microcomputer market. Okay, let's back to the segment list. What is next on the list? This one? Yeah. Okay. All right. Read values from n.a and n.b. Oh, no, over here. And then read a value from n.s. Write n.a when n.s is -1, and write n.b when n.s is 1. Write n.a plus n.b when n.s is 0. Okay, so we need this n.s value. Now I could probably make sense to move up to the right. I'm going to see how much code I can put on one node. So this is going to be move up into the accumulator. This is what we're going to be working on. So if it is equal to 0, so I guess we'll just get that out of the way. We'll jump to add. I'm going to do A for add. And then actually, let's do sum, because we'll just do A and B for their respective, which is jump less than 0 for -1 is going to be A, and jump greater than 0. Well, at this point, we know it's going to be B. So we're going to move. We need B, so we're going to move right down. We'll just move move left into the accumulator, and then that should cover that part. Then we'll jump back to the start. Let's just do start because I think I can fit that on this line. Okay. Then if we are 0, that's a sum here. So we're going to move left into accumulator. We're going to add right. And then we're going to move ACC down, right. And then we're going to jump start. And then finally, if we're writing A, we're going to move left down. We're going to move left down, and then lost my train of thought here. We need to move B into the accumulator, which is right into the accumulator. We're just dumping it in the accumulator, and then we'll go down. What are we doing? Yeah, that'll automatically restart. And then here we just need to move up, down, and we just need to move up, down. So let's look at our test output here. -1, so we should get A. So we should see -13. That's correct. That's correct. Where's our 0? Okay, we got a 0 here. What's our output going to look like there? -19. So we got 0 coming in, 29. So we should get 12. Oh yeah, because -17 plus 29. That outputs 12. Yeah, okay. We did it. That one, we're good on instruction count. We're good on node count. Cycles are a little high. I think I'm going to be okay with that. Cycles are not the easiest to optimize in some cases. I realize I missed a piece there, but we'll piece these together a little later. Okay, sequence generators. Sequences are 0 terminated. Read values from in.A and in.B. Write the lesser value to out. Write the greater value to out. And then write 0 at the end of the sequence. Okay, so we're reading an in and out, and then we're writing 0. So this is interesting, because we need to know both of the numbers at some point. We want to try to use a number of nodes. I'm looking at these 5 nodes here. I'm thinking write the lesser. So we're going to have to do some subtraction, which means we're going to have to store these values somewhere. Which is going to involve multiple nodes. So I think this node, and I guess this node will have to be, or we'll use this node as storage. And we'll do some fancy swizzling here. So I guess what we'll do is we'll move up into an accumulator. I'm just going to tank token count immediately. I'm thinking we're going to read A down and right, and then we're going to read B down, and then here it'll go right. And then this will wait on what value does it want first. And then over here, we'll do the logic of like which one's greater by subtracting them. Right, so move up, move accumulator right, move, oh no, want to move it down. Yeah, we just want to move it down. I don't need to move it right. And then we'll move, yeah, I think I overcomplicated this. We're just going to move this one down. This one will move it into the accumulator. Move the accumulator to the right here, and then we'll swap. I think it's WSAP. Look at my handy cheat sheet over here. Yes, WSAP or WSP, the value of accumulator and back are swapped. So we're going to swap that in preparation to write B. And then here we just need to move up, down. Yeah, so that's pretty straightforward. Over here, we're going to move the right value, the left value into accumulator, and then we're going to move up to the left. No, we need to sub that. Ooh, this is a tough one. So what I think I'm going to do is, for now, we're just going to move that in the accumulator, and then we're going to move that down twice. Because the first time we want to read it, we want to send it to the left. And the second time we want to read it, so over here we're going to move right, ACC. And then we're going to wait. Oh no. See, now I'm in a struggle. Because we only have 2 registers, so it can't actually determine where it's going at. So I'm gonna have to send it over here. Yeah, we're gonna leave that. We're just gonna leave that, and then over here we'll move the left value into accumulator, and we'll move the accumulator left. So that'll read it. So we're moving it left. And then we're going to sub left. We're going to sub left. So that's going to give us, let's see what that's going to give us so I can think here. All right, so we've got 36. What am I doing? I need that to go right, not left anymore. So 71 is coming down from B. 46 is here. That gets put in accumulator. And then we're at negative 25. Well, what's going on? What's going on? Move up right. 46 is coming in A. Oh, I see. I wrote this one twice. So, so I could just sub up. Yeah, okay. All right, so I've got 46 here. I've got 71 there. 46 should go to the left, and that gets written into 46. And then 71 gets subtracted. Why is 71 over here? Because I've already read it in. It's the next value. Goodness gracious, this isn't going to work. Yeah, this is the tough part, because this one's just waiting on there. So then I need to swap, and I need to move from the right into accumulator, because that's going to decide what we do. Actually, yeah, I'm just moving it twice. Once it needs to read, and then once it's going to wait. That's all I need to do. Okay. Now we got 46. Then we got 25. Okay, so once we're at negative 25 after this point, then we can do it. So if we're negative, because we put A in, A minus B, so if that's negative, then B is larger. So if we're less than 0, it's B. Otherwise, it's going to be A. So here we're going to move, this is A to the left, so we move left down, move right, and we're just going to eat it. And then we're going to jump start. Let's go back up here. Start. I'm just going to use ST for start. It's short, and it keeps the line short. I don't want to waste a line on a label unless I need to. And then B code here is going to be move right down, and I don't actually need a label start. I think I got it. Okay, so we're going to move this into the accumulator. going to move right down, and then we're going to move left into the accumulator. We'll seat that. And then that'll reset for the next one, and then you just move. Oh, no, shoot. They both need to go down, and then move right down, because we're writing them in order. Yeah, and so this is going to move up, down, move up, down, move 0, down, because that'll be the end of the sequence. All right, so we got 71 in. All right, we got 46 in memory here. We got negative 25 there. I think we're missing our memory over here, so we need to move ACC left again. Okay, so what am I doing? What am I doing wrong? Move. Move left in the accumulator, and then move the accumulator left. That's only going to be read once. I don't know what I'm thinking here. Okay, let's get this done. Oh. Yes. This one's done twice, so I don't need this node. This one's already storing that value for me. So left is going to be up. Yeah, left is going to be up. There we go. Okay, so we got 71 in memory, we got 46 in memory. We're going to do... Oh, we don't have it in memory. Okay, now we've done the subtraction. Now we've got 46, 71, and we've determined that B is larger, so we're going to move 46 down. If I can get... Oh, man, I got all of the directions wrong. That is left. That is left. Okay. There we go. Move left down, then move up down. It writes 46, 71, then it should write 0. And then we're at 29 and 71. So, are we doing good? We did it. We did it. Ooh, we were good on cycle. Wow. I'm actually surprised there. Node count's a little high. We could use one less node. And then 18 here. Yeah, I don't know. So if we use one less node, we get rid of this node, which means we need a predictable order here, or we store things in memory better here. I'm not going to try to reduce node count. My brain is already struggling a little bit there. Okay, let's move on to this one. Where are we at? Okay, looks like I missed this. We got somebody in chat. I mean, thanks for chatting, but yeah. Oh, you're advertising in the wrong space, my man. Okay, I'm struggling with this stuff. There we go. There's my X button. Okay. All right. I think I'll pause it there. This is a good kind of get back into it. So let's erase this program we didn't write. We'll pick back up here right where we left off sometime in the future.